In this video, I want to talk to you about how actually we can understand cost per click. We'll be talking about how cost per click happens for web application, what is the relationship between the number of services we use and the number of requests that is being triggered by a click. We'll also talk about how actually we predict and maintain the costing for a monthly thing for a subscription basis, and we'll also get into where actually cost per click or a cost per request makes a lot of sense for us to predict and understand the cost for keeping the web application up. So join with me, hopefully you learn something new. Let's understand what happens when the user opens where1.net. You see, the pricing or the cost for a request depends on the number of services that has been used to respond to the user. Let's look at a few examples to make this clear. To help you guys understand better, let's walk through an example using one of the key pages in the Where1 web application, that is the landing page. For purely demonstration purposes, we'll assume that the underlying services powering the page are Amazon EC2 for compute and Amazon RDS for the database. This example will give us a clear view of how the system functions end-to-end using these core AWS services. Let's get into it. Let's say I open the landing page and open where1.net. In this case, what happens is from the browser, the request first hits the EC2 service. Now EC2 service is where all my code is hosted and where my code is running to be able to respond to the user for his particular page. When the code is getting executed, it realizes that, hey, I need to fetch some data to be able to respond to this user. What it does is actually makes a call to a database service, which basically is keeping all this information stored, and it is parallelly processing a multiple requests that are coming to it. So now the database first collects this request from the EC2 service, goes to the table, fetches that information and gives it back to the EC2 server. Now the EC2 server, having got all the data, is now going to construct the HTML page, which is going to get sent to my browser, which gets ultimately rendered. So in this example, two services were used. Let's think of another example where more than just the database and the EC2 server would be used. In addition to the two example services that we used in the previous demo, the upcoming demonstration will introduce another component, which is email delivery. For this flow, we'll assume the underlying service used for sending email is SendGrid for demonstration purpose. This will help us understand how a web application can integrate with a third-party email service in helping us trigger emails when required. One flow that comes to mind is the booking service. In the booking service, along with just responding to the user with HTML and showing some web pages, it's also important that we send an email as a confirmation to the user of a booking having done successfully. So in this case, what happens when I click on the confirm booking page on my where1.net, it first goes and hits the EC2 server. Now the EC2 is the code that written there is saying that I need to send an email. Now to send an email, the EC2 server makes a request to a SendGrid server. SendGrid is what we use to trigger emails and ensure that the emails shows up in people's inboxes. Now the EC2 server makes a request to SendGrid, tells it to send this email confirmation, it triggers that, and after that trigger is successful, it goes back to the customer's browser and says, hey, your booking is confirmed. So what we have now seen is the cost really depends on the number of services that are being used, and based on the type of the request, different services are used. It's also important to understand how these services actually charge us. So what happens here is EC2 charges us based on how powerful the machine really is that executing the code. A database charges for how much memory it is going to store, and along with how much data is going to, along with how much processing and power is there behind the database server. SendGrid, on the other hand, charges us based on the number of emails we send for it on a monthly basis. So what really happens here is, for me to be able to say how much am I going to spend in this month, we make predictions as to how much traffic we're going to get. Based on those predictions, we say, okay, I want either a more powerful server like a T4 Max or probably a cheaper server like a T2 Micro on EC2. This tells us how much I'm going to spend per month on this. Similarly, even for RDS, I'm going to say that, hey, how powerful or how not so powerful and a faster server I want, and I make this decision based on my monthly prediction, and I make the purchase with my AWS cloud provider. SendGrid, on the other hand, charges me not on the power of the machine, the CPU cycle or the memory, but rather how many emails I send in a month-to-month basis. Again, this is a prediction that we do and say in this month I'm going to be sending this many emails and I'm going to purchase this tire from my SendGrid server. This way is how we are essentially saying how much traffic I'm going to get in a month and how much budget I want to allocate in a particular month for keeping this website up. Let's look at other examples where a cost per click makes a lot of sense. A good example here would be, let's say your AI or LLM chatbots. For example, ChatGPT. If we go look at ChatGPT's pricing page, they talk about something called as tokens. The way they calculate pricing is how many input tokens you send to the server, and as a response, how many output tokens it sent. So what is this magical token? A token is a way of representing the information that is coming to the server. It takes the images that you send to ChatGPT, the text that you are uploading as all, and converts them into tokens, which ultimately goes and hits my ChatGPT server. So here ChatGPT server actually is making its pricing decisions based on the number of tokens it is receiving and the number of tokens it is sending as a response. So this is a place where a cost per request makes a lot of sense because their pricing is also according to that. But in our use case, it depends really on what is happening on the server based on the request that is coming to the server. Another example could be, for example, the streaming services like let's say your Hotstar, ESPN, or your Apple TV live subscription. They anticipate a lot of spike whenever a live soccer match or a cricket match or a basketball match is happening. So we know that when the FIFA World Cup is being hosted, a lot of people are going to come in and watch that match. So what the service providers do is basically they ramp up the performance of the machines that they have on their backend for that particular time window. So if a football match is going for 90 minutes, they'll plan it like, okay, I think I need to purchase more better and higher computing power machines and keep it on active from 6:30 to 9 o'clock for that window, even though the match is being played for a shorter duration. And then they decide, okay, in this duration, I want it only these more powerful machines. So what they do is they have a base rate predictions based on how much is my normal value, how much is my mean average in the last 12 months and how much capacity I need to have. And on top of that, they add these other boxes to ensure that whenever a new match comes or a live stream where they're anticipating a lot of people to come and watch, they're going to add more power behind those machines. So this way, streaming services calculate their expenditure per month, and their cost per click is also dependent on how many people come. So as you can see, there are many ways of calculating this, and what we do most of the times is make a prediction, go and buy particular services from the AWS cloud provider or whichever cloud provider we have, and then again next month see that, hey, was this enough, was it more, and if you're anticipating a spike, hey, I'm going to add a new power behind these machines, and that's how I make my finance decisions. I hope you learned something in this video. If you have any questions, please reach out to us. I'd be more than happy to help.